Welcome all, welcome back at C Square. In this lesson we'll talk about slope on the first part, or a little bit here on this slide, and also we're going to talk about parallel and perpendicular line in rectangular lid. The first thing you see here is the slope. The slope is the ratio of rise over run, how I said here. And you notice what the rise is, the y change, if you want to call it like that. The run is the exchange. There is a formula, which you'll see it right here. M equals y2 minus y1. That is the, well, like I said, the y change over x2 minus x1, which is the exchange. Rise over run, as I said before. Okay, so let's take a look now. Whenever you look for parallel lines, for example, we can look to the slope of these lines, and I said here a very, very strong statement, if and only if. That's very important to remember. Okay, it goes both ways. So this statement here says two distinct non-vertical lines are parallel if and only if the lines have the same slope. So that means if they have the same slope, they are parallel lines, and the converse is that if they are parallel lines, they have the same slope. The last statement here said the vertical lines are parallel. So I want you to take a look on this picture. Yeah, line A and B you see here are non-vertical lines, and they are parallel. They have the same slope. You can pick any 2 points and see the slope of these two lines is the same. On the other hand, lines C and D are vertical lines, and they are parallels. By the way, if you're wondering what is the slope of a vertical line, that is undefined. Both lines C and D have a slope that is undefined. On the other hand, for the perpendicular line, very important, again you can see that statement, if and only if two distinct non-vertical lines are perpendicular, if and only if the product of their slope is -1. And that sounds like this. We have two lines, let me call it M1, the slope of the first line, M2, the slope of the second line. That means the product is -1. Another way to look at is that M1 is the negative reciprocal of the M2, or vice versa. The slope of the second line is the negative reciprocal, or the opposite reciprocal, in fact, of the first line. These are the things I'm going to use here. And the last statement here, vertical and horizontal line are perpendicular. We can notice here that C and D, these two lines, are perpendicular. One is vertical, one is the horizontal. A and B, if you take a look to the slope of these two lines, the product is -1, or they are the opposite reciprocal of each other. We'll see that in my next problems. And let's start with this first example, where we have to see if line AB and line BCD are parallel, perpendicular, or neither. So how are we going to do that? We're going to find the slope of each line. So we're going to start with line AB, which is defined by the point A and B. Okay, so I'm going to use the slope formula. I'm going to call this one M1, and that will be y2 minus y1, if you remember the formula, over x2 minus x1. Okay, so in this case, since we talk about the line AB, let's label for the point A x1 and y1, point B x2 and y2. So this slope in our case will be 2 minus 1 over -2 minus 2. And that means this slope is going to be 2 minus 1, that is 1, over -4, or simply -1 over 4. This is the slope of line AB. Now, very similar, we're going to do the slope of the second line CD. And now I'm going to label this on x1 and y1, x2 and y2. As you know, you can switch them, that's not a problem. This second slope, using the same formula, it's going to be what? 5 minus 7, right? y2 minus y1 over 4 minus negative 4. Yeah, so we're going to have here 5 minus 7, that will be negative 2, 4 minus negative 4, that will be 8. We can simplify this one, and this is going to be negative 1 over 4. This is the second slope of the line CD. As you notice, these two slopes are the same. So if the slopes are the same, then lines are parallel lines. So I'm going to say that here, AB parallel with CD. Okay, and again, we know that because the slope are the same, negative 1 over 4. Verify your answer by graphing these two lines. Like you can see that here, we have these two lines, and we can see the lines are parallel also in the graph. My next example, very similar. We have to determine if AB and CD are parallel, perpendicular, or neither. So I'm going to do the same math. I'm going to start with line AB. And again, I'm going to write the slope formula. y2 minus y1 over x2 minus x1. And in this case, we're going to have, again, I will suggest you to label the points x1, y1, x2, y2. And we have 2 minus 1 over negative 2 minus negative 7. And that will be 2 minus 1, that will be 1, and negative 2 minus negative 7, that will be positive 5. So 1 over 5 is the slope of line AB. Let's take a look to the slope of the second line, line CD. Okay, line CD, and we have here x1 and y1, x2 and y2. So the slope of this line CD, which I call it M2, will be 6 minus 4 over 6 minus negative 3. So that will be 6 minus 4, that will be 2. 6 minus 3 is minus negative 3, that will be 9. So this is the slope of the second line. Now let's take a look to these two slopes. These two slopes are not equal, right? They are, one it's 1 over 5, the other one it's 2 9ths, and their products, if you want to call it like that, is not negative 1. They are not the negative reciprocal. So these two lines are neither, how we call them, which means neither parallel nor perpendicular lines. Let's see that in the graph. And you see, it's kind of tricky. It looks like they are very parallel lines, but they are not. They are not. They are very close, but they are not parallel lines. You see, the picture sometimes can mislead you. So the algebra is the answer for this problem. The slopes are different, so they are not parallel, and they are not negative reciprocal, so they are not, or opposite reciprocal, they are not perpendicular. Third example, we have a picture here, and looking to this picture, it seems for me like these two lines AB and CD are perpendicular, For sure they are not parallel. We can see that in the picture, but I will say let's check it. How are we gonna check it? We're gonna find the slope of each line algebraically. Start with line AB, and you notice we have the points. Again, the slope is gonna be y2 minus y1. Let me write it again, over x2 minus x1. So in this case we have what? Let's call this one x1, y1, x2, y2. Label them. I will say that is the safest way. And we have here 1 minus 7 y2 minus y1 over 1 minus negative 1. 1 minus negative 1, it's x2 minus x1, like I said here. So there will be here 1 minus 7 is negative 6, 1 minus negative 1 is positive 2. So this slope will be negative 3, which kind of makes sense. If you take a look to line AB, it's going down from left to right. We should get a negative slope. Let's take a look to line CD, the second line. And we're gonna use the same formula of the slope for this m sub 2. We're gonna use the same formula, y2 minus y1 over x2 minus x1. The only difference, be careful what your x's and y's are. So label again, I will say that x1, y1, x2, y2. So we have here 5 minus 2. And that is y2 minus y1, and 6 minus negative 3. That will be x2 minus x1. And that 5 minus 2 is 3, 6 minus negative 3 is 9. So we get 3 over 9, which is 1/3. So let's take a look to the second slope. And what do we notice here? These two slopes are negative reciprocal or opposite reciprocal, if you want to call them like that. The reciprocal of negative 3 is negative 1 over 3. If we change the sign, we get this 1 over 3, or vice versa. The reciprocal of 1 over 3 is 3. If we change the sign, we get negative 3. So these two lines are perpendicular. Another way to see it is, like I said, the product m1 times m2 is negative 1. So if that happened, then the lines are perpendicular. Then AB perpendicular on CD. Okay, so now we are sure these two lines are perpendicular. I can make a right angle here. We know that because these slopes are negative reciprocal, opposite reciprocal, or the product is negative 1. On the next part of the lesson, we're going to take a look to some representation for non-vertical line, how I call them here. The first one is what we call the slope-intercept form. Y equals mx plus b is right here, where m is the slope. So this one is the slope, the first letter in this form, and b, the second, the last guy here, is the y-intercept. So we have here an example, y equals 2x plus 1. That means the slope is 2, the first number, and the y-intercept is 1. Be sure on that y-intercept you also see that as an order pair 0 and 1. Sometimes that is very useful, especially if you graph. The second representation for a line, which is very useful, it's what is called the point slope form. You see it here, y minus y1 equals m times x minus x1, where m is the slope, the same slope we talked in just a minute ago in the slope-intercept form. The only difference, now we have a point, any point. If you have a point, of that line, you can use this point slope form and write an equation. For example, here we have y plus 5 equals 2 times x plus 3. We know the slope is 2, and the point, be careful, you have to make it negative here, right? Because it's y minus y1. So that will be negative 5, you see it here. And the same thing here, so this positive becomes negative. The same thing here, the positive 3 becomes negative 3. Very, very careful of these things. But very important form. Now I want to mention something, that the slope-intercept form is unique. It's only one. However, the point-slope form depends on the point you have. In this case, for this example, the point was negative 3 and negative 5. Horizontal line equation. So we can write the equation of horizontal line like y equals b, where b is the y-intercept. So you see that here y equals 3 is an horizontal line that has a y-intercept of 3. Now we have also something very similar for vertical lines. Very important, x equals a number. A in this case is the equation of a vertical line, where a is the x-intercept. We have an example here. X equals 2 is a vertical line that has an x-intercept of 2. Let's be sure we have a picture for each one. I sketch a graph here. 1, 2, 3, 1, 2, 3. This is the graph on horizontal line. Okay, this is the x-axis, this is the y-axis. Don't be confused. Yes, x-axis is a horizontal line, y equals 0. Okay, very similar. This one we have, what did I say? A vertical line. This is the x-intercept of 2. Oops, I miss it, but that's it. This is x equals 2, and this is x-axis, this is y-axis. Yeah, y-axis is a vertical line, it's x equal 0. Okay, so now we can take a look to the next part of the lesson, which is nothing else than identifying whether lines are parallel, perpendicular, or neither, based on the equation. So on this example, we notice we have line A, which has the equation y equals negative 3x plus 5. Using this slope-intercept form we just discussed about, we know the slope is negative 3. So m equals here negative 3. Well, what about line B? If we look to this one, this is the other form I just mentioned, y minus y1 equals m times x minus x1. And the only thing we need here is this negative 3. Now we do not have a parenthesis there, but really doesn't matter because we still can see that slope of negative 3. If you distribute here, you're gonna get mx. So here we see that mx. So the slope here is also negative 3. So if we look to these two guys, they are the same, which means they are parallel lines. So these two guys are the same. That means nothing else than line A and B are parallel lines. Let's go to part B. Part B, y equals 3. That is a horizontal line, right? And line D, x equals negative 2. That is a vertical line. So a vertical and an horizontal line, these are perpendicular. C perpendicular on D. Whenever you have this case, vertical and horizontal. Now let's take a look to part C. Part C, very fast, we can see the slope in this case is this positive 2. If we move to the second one, the slope of the second line again is this negative 1/2. Even though we do not have parentheses like in the slope point form, we know that is the slope. So now let's take a look to these two slope, what do we notice? 2 and negative 1/2, they are negative reciprocal, these two, opposite reciprocal. Another way to say it, the same thing. So that tells us line F and G are perpendicular lines. And let's take a look to the last one, where we see this -5 is the slope. Again, I use the slope-intercept form for identifying the slope. And here the slope is -1/5. So this is the case that sometimes students have trouble with. They look, oh, these are perpendicular line. No, they are not. They are reciprocal, but they are not opposite reciprocal, these two lines. So these two lines are neither parallel nor perpendicular. Okay. On my next example, we're gonna look how to sketch graphs of parallel and perpendicular line using their slope and the slope-intercept form. So, given the graph of line L that passed through these 2 points, so this is line L. Sketch the graph of the line T that is parallel with the line L and goes through this point 0 and 1. Okay, so it's going to go through this point. So the first thing you want to do is to find the slope of this line. And probably the best way to do it is to use these 2 points that are given to us. It's the safest way. You see, I use this graphical way to find the slope. This is a rise of 2 and a run of 1, 2, 3, 4, 5, 6. So the slope of line L will be 2/6 rise over run. But don't forget, it goes down from left to right, so it's going to be a negative. So it's going to be a -1/3. Now, we need the line that is parallel with L, line T, right? So what will be the slope of that line? The slope of line T will be the same, -1/3. Why? Because line L and T are parallel lines, so they have to have the same slope. So how do I sketch the graph? From here, I'm going to use the same slope of -1/3, which means I can go up 1 and 3 left and get a point, and that's good enough. You can draw the line. Also, you can go 1 down, 3 right, and get another point. I did that just because I need that to be more accurate on my screen when I draw these parallel lines. Okay, so now the next thing is the last part here. It says write the equation of the line T. We know the slope is -1/3. The y-intercept is this point C, which is at 0 and 1, which means B is 1. Okay, so now we have the equation of that line. T will be y equals m -1/3 x plus b1. This is the equation of that line. Okay, let's move to part B, where we have to find the equation of line R that is perpendicular to L and goes through 0 and 1. So one more time, we have the slope of line L. We did it on part A, -1/3. Now we want the slope of the line R. Flip this guy and change the sign. That's the way I do it mentally, and in this case we end up with a slope of 3. The slope of the perpendicular line R is 3. Okay, let me write that here. L perpendicular on R. Now the intercept is going to be the same, 0 and 1, the point we have. So right away I can write the equation y equals mx, so in this case 3x plus b. That is the equation of plus b, which is 1. Okay, this is the equation, and I'm going to do the graph in a moment. So I did the last part here. I wrote the equation. Let's do the graph. From this point, see, we need a slope of 3. The best way to approach this one, go 3 down, 1 right to get a point. 3 down, 1 right. Okay. If you ask yourself why 3 down, 1 right, that would be a slope of positive 3, right? 3 down, negative 3, 1 left. I supposed to say, my fault. A negative 1, that will be positive 3. Okay, so this is a line R that has a slope of positive 3. So one more time, from this point C, I went 3 down, that means negative 3, 1 left, that means negative 1 if you think like a number. That's the reason we end up with a slope of 3 algebraically. You can see better the picture here. These are the two cases, parallel line to AB and perpendicular line on AB. Very similar approach. We have, you notice the same line AB. The only difference, the point C now is not on the y-axis, is not an intercept. Other than that, it's kind of the same thing. You find the slope of line AB, which we did it, right? But let's say we don't know it. Remember, this was 2, this was 2, 4, 6. So the slope of line L is negative 2 over 6 or negative 1 over 3. So again, from this point now, you're going to go 3 down, 1 left. I'm sorry. We need to write the parallel lines, so we're gonna go 1 up, 3 left, 1 way, or 1 down, 3 right. That will give us a slope of negative 1 over 3. And now we can draw a decent line. So again, this is the line T that is parallel with line L. Okay. And the next thing is how to write the equation. Now we're going to use that point slope form, y minus y1 equals m times x minus x1. And we have y minus, remember the point C is right here, and this is x1 and this is y1. So y minus 2 equal m, that is negative 1/3. And now parentheses, don't forget x minus x1, x minus negative 2. This is a good form if you are asked only the point slope form. I'm going to write the equation of line T, which I guess tells me to write the slope intercept form. So y minus 2 equals negative 1 over 3 x plus 2. Let me put a parenthesis. We're going to use the distributive property. And then negative 1/3 times 2, negative 2/3. We have to do one more thing. We're gonna add 2 here. Now, I'm gonna add 2 here, but in a different way. 6 over 3 is that 2. I like this 6 over 3 because then we have the same denominator. So what do we get now? These plus and minus 2 cancel out. That's good. That's the reason we did it. A negative 1 over 3x. And then we have negative 2/3 plus 6/3 plus 4/3. If you take a look to the equation, the graph we have on this picture, yeah, it looks pretty accurate. Looks like this one is between 1 and 2, the y-intercept. Okay, let's move to the second part. The second part is to write the equation of the perpendicular line. So one more time, the slope of line L is negative 1/3. How much is the slope of the perpendicular line? If you remember, we flip it, negative 3/1, we change the sign, that would be 3. We did that in the previous problem, right? So that's the thing I was thinking to do a couple minutes ago, because I did not pay attention, but now I know I'm gonna go 3 down, 1 right. 3 down, 1 right. And I think I have enough points to sketch a decent line. Unfortunately, I cannot do more points, so I'm gonna try to be accurate with these 3 points. Of course, use a straight edge or ruler. Okay, this is the line R, which is perpendicular on line AB. Let's see the equation. How do we get it? The same way. We're gonna do y minus y1. Again, the point is the same, so it's going to be the same thing, y minus y1. Y minus 2 equals, now the slope is different, is positive 3, x minus x1. So we have here y minus 2 equals 3 times the quantity x plus 2, distributive property now. And we have here 3x plus 6. And the last step, add 2 on both sides. So we have y equals 3x plus 8, which kind of look very accurate. If you take a look, this red line keep going up, 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 and I think it's gonna cross the y-axis at 8. Okay, I think on the next slide, yeah, you can see a better picture of this situation. And that's it for today. I hope you enjoyed this lesson, and click the like button and come back on C-Square for more help. Thank you.